Robin bring you testing to BS7671 2001, the IEE wiring regulations. Legislation now covers virtually every aspect of electrical systems, not only wiring of the installation itself, but also fixed and plug-connected equipment. The Electricity at Work regulations is the statutory instrument to which electrical systems in the United Kingdom must conform. All Robin's current test equipment complies with requirements in British Standard 7671, as well as recommendations in IEE Guidance Note 3 Inspection and Testing. Robin supply equipment for testing electrical installations, as well as a comprehensive range of portable appliance testers and multimeters. From its headquarters in Norwich, Robin supply a network of distributors with innovative instruments, manufactured to the highest quality standards, all supported by customer training and service. The current range of Robin instruments featured in this programme meet the requirements of both British and European standards. The Electricity at Work regulations requires personnel who carry out inspection and testing, verifiers, to be competent. Competency implies a suitably qualified electrician or electrical engineer having the necessary education, training and experience to prevent danger, not purely qualifications. Installations which conform to standards laid down in BS 7671 may be regarded as conforming with relevant parts of the Electricity at Work regulations. Electrical installations compliant with the objects, effects and fundamental principles of the British standard should be certified as being compliant by virtue of inspection, testing and certification. It's essential the verifier is familiar with requirements of Part 7 of the wiring regulations and relevant parts of Guidance Note 3. Section 2 of Guidance Note 3 is for initial verification, new works, and Section 3 for periodic verification of existing installations. Sections 4 and 5, together with the appendices, are necessary for reference in conjunction with Sections 2 and 3. The content of this video is not intended to replace BS 7671 or IEE guidance material, which should be consulted in all cases of doubt. A clear understanding of the layout of the regulations is important so that each part can be identified. It's important the verifier has a clear understanding of the installation and how it's been designed and constructed. Past test results are necessary for periodic verification. Information relating to all aspects of the installation must be provided, including specification of equipment, type of supply and maximum demand. Earthing details and installation design data must be available. This information is also required for documentation purposes. The verifier, together with the user, must have information identifying the purpose of circuits, together with fuse and circuit breaker ratings. It's therefore important to ensure the installation is properly equipped with labels and notices outlined in the regulations. The word inspection embraces human senses including sight, touch, hearing and smell. Such senses, where practicable, are used to carry out inspection before and as necessary during testing. Live testing can be hazardous. People must be kept clear of working areas as necessary to prevent danger. Equipment should be removed from circuit outlets prior to testing, and any electronic devices should be disconnected where practicable, or equally effective measures taken to prevent damage. The correct sequence for testing is paramount and must be followed. Before connection of supply, confirm continuity of all protective conductors in the installation. Confirm continuity of all circuit conductors of ring final circuits. Determine insulation resistance of fixed wiring. Tests of site-applied insulation and protection by separation of circuits are specialized. Protection by barriers or enclosures is to prevent direct contact with live parts. Insulation of non-conducting floors and walls is again a specialized test. Polarity must be confirmed at all outlets. Earth electrode resistance, where applicable, must be determined. Now, with a supply available, confirm correct polarity at supply intake. Confirm correct polarity at all accessories. Determine earth fault loop impedance at all outlets. Determine prospective fault current at all relevant points. Verify correct operation of residual current devices where fitted. Verify correct operation of switches, circuit breakers and isolators and all other switchgear. Correct test equipment must be selected and prepared for use. As low conductor resistance is to be measured, the test leads resistance, which will be in the test circuit, must be compensated for prior to testing. If a wander lead is necessary to extend the short instrument test leads, this must be included in the nulling process. Continuity tests are for the purpose of verifying that protective conductors are sound and correctly connected. There are two suggested methods of measurement. Method 1 is probably the most common. First, prove the conductors to be tested are isolated from all live or charged sources of energy. A temporary link can now be made at the distribution board between the circuit phase and protective conductor. A test between phase conductor and protective conductor at the furthest point of the circuit will reveal the R1 and R2 for the circuit. The ohmic display between the circuit phase conductor and circuit protective conductor is recorded on the test result schedule. Remember to remove the link after testing. Method 2 uses a wander lead connected between the consumer's main earthing terminal and continuity tester and can be used for verifying the protective conductor continuity of a radial circuit. With the short lead connected to the instrument, contact is made to every accessible exposed conductive part in the installation. The conductor must be soundly reconnected before reinstating the supply. It's also commonly used for verifying continuity of main equipotential bonding conductors. Metal conduit and metal trunking have in the past been commonly used as a sole circuit protective conductor. Such enclosures should periodically be given thorough inspections, as many will be found to have not stood the test of time. A low ohmic test can be carried out on the protective conductor circuit with suitable test equipment. It's important to ensure that a ring final circuit phase, neutral and protective conductor is soundly and correctly connected and continuous. After effectively isolating the supply to the ring final circuit and proving dead, the conductors are disconnected and their resistance measured and recorded. It can be seen from Table D of the Practical Guide to Testing that the conductor resistance can be directly related to conductor length. To confirm the absence of a bridged ring, temporary connections are made between the ends of opposing phase and neutral conductors at their origin. A resistance measurement is taken between L and N terminals at each outlet on the ring, including spurs if present. All measurements should be virtually the same, other than those of connected spurs. A temporary connection is now made between the ends of opposing phase and protective conductors at their origin. Tests are carried out between phase and protective conductor terminals at each outlet. The highest recorded instrument reading will be the circuit contribution R1 plus R2 to the system phase earth fault loop impedance ZS. Verification of correct polarity at equipment and accessories is important where single-pole switchgear and protective devices are used in an installation. All single-pole switches, fuses and circuit breakers must be tested to confirm connections are made in an unearthed conductor. Tests at accessories will include Edison screw and single-contact bayonet cap lamp holders where present. Insulation of live parts is obviously very important to prevent risk of electric shock and to prevent excess current flow in unwanted paths. Its effectiveness must be tested between live conductors and between live conductors and earth. Before testing, it's important to disconnect equipment or take other measures to prevent damage to voltage-sensitive components on the circuit being tested, which may be damaged by the test voltage. Such equipment includes dimmer switches, delay timers, electronic starters for fluorescent lighting, and similar. Where electronic filters are present between exposed conductive parts of equipment and live parts, a test between live conductors and earthed exposed conductive parts only is made, not a test between live conductors. The test to earth must be carried out on the complete installation with the main switch off, lamps removed and equipment disconnected. Fuses must be in, circuit breakers closed and all final circuit switches closed. The resistance between live conductors and between live conductors and earth must not be less than half of 1 megohm for compliance with BS7671. For compliance with IEE Guidance Note 3, not less than 2 megohms for 230 volt and 400 volt systems. Two-way switches must be operated in both positions to include all switch wires. 2 tests are therefore needed. Large or complex installations involving multiple circuits can be subdivided and tested in groups of lesser numbers of outlets. Throughout BS7671, reference is made to use of barriers and enclosures to prevent direct contact with live parts. Equipment manufactured to current British and European standards should comply. TT systems are reliant upon a sound connection with the mass of earth for protecting installation users against indirect contact shock. Electrical tests must confirm an effective earthing system to prevent hazardous shock voltages appearing on exposed metalwork. The resistance of the consumer's earth electrode relative to ground should be in accordance with recommendations in the current edition of the Code of Practice for Earthing. Before testing, the supply to the installation must be isolated and the electrode disconnected from the consumer's main earthing terminal. Using a dedicated earth resistance tester or multifunction tester having this facility, 2 temporary earth spikes are driven into the ground at the distances specified in the instruction manual of the test equipment. To ensure resistance areas do not overlap, 3 readings are taken following movement of the potential electrode. Where an RCD is used for indirect contact shock protection, IEE Guidance Note 3 permits measurement of electrode resistance using a loop impedance tester. In the event of a phase fault to exposed conductive parts of consumer's equipment, sufficient current must flow to enable rapid operation of the circuit protective device. The earth fault loop impedance test will measure the impedance of the fault current loop path. First, confirm correct incoming polarity. The network phase earth fault loop impedance, referred to as ZE, is first measured. The supply is effectively isolated to circuits and the test conducted between the means of earthing and an incoming phase conductor. With the installation main earthing terminal reconnected to the means of earthing, the supply is reinstated and a ZS measurement taken at all outlets on the circuits. The highest recorded impedance is recorded for each circuit. The recorded impedance can be adjusted to take account of ambient temperature and cable characteristics and compared directly with design values from BS7671. To avoid calculations, the measured value as appearing on the loop tester may be compared directly with pre-calculated values such as shown in Table J of the Practical Guide to Electrical Installation Testing. Fuses and overcurrent circuit breakers have a declared limit to their capability of breaking and, in the case of circuit breakers, making a fault current. Their limited breaking capacity must not be exceeded. Tests for polarity and correct rotation of three-phase supplies should be performed where appropriate. Electrical tests may be conducted to determine fault levels at distribution boards and consumer units where protective devices are fitted. As an approximation, single-phase short-circuit current values may be doubled to assess three-phase conditions. BS7671 requires the effectiveness of residual current-operated devices, including RCBOs, to be verified by a test method independent of any test facility provided in the device. With loads disconnected from the circuit, the RCD tester is connected to a circuit outlet and tests performed. The RCD is normally tested on the positive and negative half cycles of the supply waveform, 0 degrees and 180 degrees. Some RCDs may be less sensitive and slower to operate in one half of the waveform to the other. Two values are taken, and if different, the longer time is recorded. Switchgear and control gear assemblies must be subjected to a functional test to confirm their ongoing acceptance for their intended purpose. Regulation 4.2 of the Electricity at Work regulations requires electrical systems to be maintained. Chapter 7.3 in BS7671 requires all electrical installations to be periodically inspected and tested. The installation user should be informed of the need for periodic testing with the next recommended inspection date recorded on the electrical installation certificate or periodic inspection report as appropriate. Legal requirements covering the frequency of inspection and testing for petrol stations, caravan sites and theatres are listed in IEE Guidance Note 3. Robin offer a dedicated range of test equipment conforming to the requirements of BS7671. IEE Guidance Note number 3 makes it clear that recorded test results must be valid and accurate. It follows that instruments used for testing must be periodically checked for their accuracy. During the construction of an installation and on completion of the inspection and testing activity, documentation must be provided to the person ordering the work. An electrical installation certificate and inspection and test result schedule must be provided for new installation work. An electrical minor work certificate is needed for minor alterations and additions which do not include the introduction of a new circuit. A periodic inspection report and inspection and test result schedule is required for verification of existing electrical installations. Robin provide a comprehensive range of documentation for fixed electrical installations, portable equipment maintenance generally referred to as PAT testing and logbooks, fire alarm and emergency lighting system certificates and logbooks. The illustrated Practical Guide to Electrical Installation Testing includes unique tables and test methods which enable circuit cable lengths to be found by reference to instrument test results. In addition to manually recording installation test data, software programs are available to record test result information, thus speeding up the certification process and reducing the possibility of errors occurring. Some of these software packages are compatible with handheld computers, which can be taken out on site to record data electronically for later downloading to a desktop computer. The regulations provide us with the guidance to achieve safe electrical installations in the interest of employers, employees, and the self-employed.